Okay, here to lead our next session, Driving the Change, Sustainable Future of Electric Vehicles, welcome Daniel Grist to the stage. Daniel sits on Edmonton's Energy Transition Climate Resilience Committee and chairs the Transport Subcommittee. He is an energy consultant with Revolve Engineering and has previously worked as a sustainable transport consultant and analyst for the UK-based Centre of Excellence for Low Carbon and Fuel Cell Technologies. Welcome Daniel and our panel of speakers.
Hello. Okay. Thank you, Erin, for that introduction. Welcome to Driving the Change session. I'm Daniel Grist. For the next 45 minutes, we'll be delving into the sustainability of electric vehicles. If I can define what we mean by sustainability, it would be meeting the needs of today without compromising on the ability of future generations to meet their needs. With that in mind, Will York, who's our first speaker, will be demystifying the production and sourcing of materials. If you have ever found yourself concerned that some coal on our grid may mean EVs are not as clean as they claim to be, or fretted about the unknown impact of carbon emissions from battery production, you should stick around for the first 10 minutes to hear his presentation. Our second speaker, Patrick Danielson, will then discuss whether electric vehicles meet our needs today. If you find yourself anxious regarding EV performance, such as range, charging speed, or winter performance, this is the presentation to hang around for. As we go through, please hold your questions until the end of the second presentation. 10 minutes is not enough to cover these topics in detail, so after the two 10-minute presentations, if you can stick around, we'll do a 25-minute Q&A session where we can hopefully take advantage of their specialist knowledge. So to start us off, please welcome William York to the podium. He's a senior engineer with ATCO Electric and serves on the board of directors of the Electric Vehicle Association of Alberta.
Thank you for that introduction. All right, so the EV Association of Alberta is a nonprofit association. Our mandate is to accelerate the advance of sustainable transportation through education, awareness, and advocacy. We have over 3,000 members on social media. They come from diverse professional backgrounds, dentists, doctors, lawyers, engineers, business owners, students, private business owners, and even oil and gas workers. We even have some anti-environmentalists, and they're buying electric vehicles because they don't want to pay taxes on their fuel. So we even have some libertarians within our group. So it's a very diverse group. About me, I have a bachelor's of science in electrical engineering from the University of Alberta. I'm one of the directors of the Electric Vehicle Association of Alberta as well. I've driven over 80,000 pure electric kilometers since June of 2018. That's when I first acquired my electric vehicle. I also have 10 years of experience in the electric vehicle industry, working for an electric utility. And I have installed close to 50% of Alberta's fast charging infrastructure through my professional job. And I want to start this presentation by saying that there is no such thing as a free lunch. Electric vehicles do have an impact on the environment. They do carry a carbon footprint, but numbers matter. And it turns out that driving an electric vehicle and purchasing an electric vehicle results in less greenhouse gases than driving an equivalent gas-powered vehicle. But there is an impact, and that's what we're going to discuss today. So, what are critical minerals? These are the building blocks for the digital and clean economy of tomorrow. So, we cannot create wind turbines, solar panels, electric vehicles, or electric vehicle batteries without the mining of these minerals. And today, the total global output of these minerals is vastly underneath what we need to achieve our climate change goals. So the word rare, when it's used for critical minerals, doesn't exactly mean that there is low elemental presence on Earth. In fact, it means that there are geographical challenges. Maybe it's concentrated in a country that has poor environmental standards or poor human rights standards. The processability could be low. It could be difficult to, with today's technology, to extract these minerals out of the earth. And there could be problems with these projects being long cycle. So something like an open pit mine or an underground mine is an extremely long cycle project and takes a lot of time to get past permits and get past regulations in order to start producing the minerals at scale. So this is the geographic distribution of some of these rare elements that we need to create electric vehicle batteries, for instance. You can see that a lot of these countries are problematic because they are either non-developed or we're currently at war with them. So this is a challenge that the that developed nations are going to have to overcome in order to meet the production demands of electric vehicles globally. So what elements are in an electric vehicle and what elements aren't in a gas vehicle? So we have copper, lithium, nickel, manganese, cobalt. In a gas vehicle, we only have copper and manganese. In the typical electric vehicle, you have over 10 times the amount of critical minerals when compared to a gasoline vehicle. So there are more critical minerals in the average electric vehicle compared to a gas vehicle. These are the most common mining methods. So you have underground mining, placer mining, which is basically utilizing natural flows of water in order to extract minerals from that water. It's not a common mining method. In fact, it was more common with the gold mining of the gold rush heyday. Then you have surface mining, which is obviously very energy intensive and has a large impact on the landscape of your development site. And then you have in situ mining, which is actually very common in Alberta. There's in situ oil sands processes that are actively in development and currently producing oil all over the province today. So here's a breakdown of where some of those critical minerals come from, what mining methods are most commonly producing them. You can see that for the lion's share, it's either surface mined, underground mined, or in situ mined. So why is lithium such an important element for electric vehicle batteries? And the reason for that is that it's a very low atomic mass. There's only about 3 protons and 3 neutrons in the atom. And this means that it has a very low atomic mass. It's a 3-electron outer shell, and that last electron in the outer shell is weakly bonded to the nucleus of the atom. So the lithium ion is the most natural manifestation of this element in the universe. And because of its low mass and that affinity to become an ion, it has a very high specific energy, which means relative to its weight, it can carry a lot of energy. And this is what's key for it to be a battery element. So there is no element quite like lithium when it comes to energy storage, and that's why it's the element of choice for batteries. Now, there are different cocktails when it comes to making an electric vehicle battery. What do you pair the lithium with? Nickel cobalt is the most common form of lithium-ion battery that you see out there, because although it has a high cost, it has a very high specific energy, so it carries a lot of energy relative to its weight. And many of the EVs in this room, all of the Teslas that I can see, are all nickel cobalt lithium-ion batteries. Though increasingly with low-range EVs, you're starting to see lithium iron phosphate, which you can see on this graph that I have up here, is a lower cost, but also a lower specific energy. So this is an ideal battery chemistry for lower range electric vehicles. And this is probably a battery chemistry that we're going to see more often as electric vehicles in the lower range become more popular. So when we look at lithium specifically, 2 countries have it in real abundance, and that would be Chile and Australia. Though in a couple of slides, I'm going to show you a very pleasant surprise for something right in our backyard. And it's either found in hard rock formations or in brine. So this means that lithium is literally dissolved in water. And in places like Chile, they pump that water, that lithium-enriched brine, out from under the earth, out in the aquifers, into what's called a salar field. And this field just uses the power of the sun to evaporate the water, and all you're left with are fields of white. So this is lithium hydroxide or lithium carbonate, sorry. And they literally just scrape this off the surface. The salar fields are only about centimeters thick, and they're just very, very vast. They fill up this room with water, just a centimeter thick. They let the sun evaporate it, they scrape off the lithium and ship it to a refining facility. So here's some more photos of the lithium salars. Okay, here's a story right in the Alberta backyard. This is the Leduc aquifer. It contains 6.3 million tons of lithium. So that puts us at the 7th largest known reserve of lithium in the world. In fact, it wasn't on the previous slides because it hasn't been fully measured and indicated yet, but there's a ton of lithium in there. This aquifer is massive. It's about as tall as Stantec Tower, so close to 450 meters in height, and 45 kilometers. Yes, you heard that right, kilometers across. When you're driving from Edmonton to Calgary, you are driving past one of the 7th largest known reserves of lithium in the world, right in the backyard of Alberta's oil and gas industry. In fact, Leduc, this aquifer, was what started the oil and gas industry in Alberta in 1947. This is where oil was first discovered. So it's almost been tapped entirely dry of its oil and gas resources, and all that's left is this lithium-enriched brine. And there are companies like E3 Metals, this is their investor slide, that are working on a technology called direct lithium extraction to extract this lithium from the aquifer. Now, the great thing about this project is that it will be carbon neutral, and it will actually result in net fresh water being dumped back into that aquifer. So unlike the salar fields in Chile, where the water evaporates out of the aquifer and depletes the aquifer, causes some ecological problems, this one will be fully restorative, so the water will go right back into the aquifer. This is an image of one of their prototype collector sites that they hope to build by 2026. How does it work? It's essentially a water softener, but for lithium. So they have this cylindrical column that has beads inside of it that have an affinity for the lithium ion molecule, and the lithium has, it attaches to those beads. They just let gravity drain the lithium-enriched brine through the beads, and then they wash off the lithium after. And this is maybe the future of lithium production in Alberta. So here's an outline of their resource area and their development area in Alberta. Really quickly, changing steps here, I want to talk quickly about EVAA's stance on ethics, because I know this gets brought up a lot, that even though we could ethically source lithium, there are still some problematic minerals such as cobalt that get sourced in third world countries like Chile, for instance, and there are concerns with child labor and human rights abuses. So EVAA unequivocally condemns any child rights and human rights abuses that take place. But this isn't unique to the electric vehicle industry. This is a global problem present in many industries, including textiles, coffee, chocolate, many goods that we source. Basically, any industry that has a global supply chain is vulnerable to these human rights abuses. And so the answer is not to buy electric vehicles or to stop buying coffee or to stop buying chocolate or textiles. It's to encourage governments to sanction and regulate and clean up the industries that have these abuse records. This is one of my last slides. Touching really quickly on recycling, we need 3 things for there to be a thriving recycling industry. Number 1 is volume. None of these vehicles are being produced in high enough volumes yet to justify a recycling plant. So if you think about it, if you operate a recycling plant, you need to run that thing 365 days a year. but there's not enough batteries being retired from the fleet of electric vehicles in order to do that. So we need these manufacturers to start cranking out huge numbers of vehicles so that as time progresses, that's the second thing, time, the oldest electric vehicle is only about 10 years old. The Tesla Model S, over in that corner over there, and the Nissan Leaf, they've only been in production since 2012. So how could there be enough vehicles entering retirement when they're still driving on the road? So we need a high volume of vehicles, we need time, and we need it to be cheap. And it's actually true today that it is much cheaper to recycle a lithium battery than it is to mine the raw material. So that's already in place, we just need time and the volume. And the next speaker that's coming up is going to talk about that, what Volkswagen is doing to meet the demand of electric vehicles globally. And there are companies that are getting into the recycling game. Lithion and Lifecycle are two companies that I can point to that are actively able to recover about 95% of battery materials and put them into another battery. So that's not something you can do with a gasoline-powered vehicle. Once we extract the oil and gas resources, we're unable to ever recycle the petroleum products that get burnt. So yes, mining materials for electric vehicles is GHG intensive, but the recycling of them is much less GHG intensive and much cheaper. So there will be a thriving recycling industry. And with that, I will pass it to the next speaker.
Thank you very much, William. So there's a whole lot to unpack there, so please remember your questions so we can have a robust period at the end. But please welcome our next speaker, Patrick Danielson. He's the Director of Product Planning at Volkswagen Canada. In this role, he's tasked with managing the future of the brand's Canadian product portfolio with a particular focus on the transition to electrification.
Good afternoon, everybody. Pleasure to be here in Alberta to talk about electric vehicles, specifically because when we think about Alberta, we don't tend to think about electric vehicles. And while some of that, it's easy to assume, is because there is a lack of demand, that's simply not true. We at Volkswagen, and we certainly believe other automakers that we compete with, see the opportunity for electric vehicle sales here in Alberta and across Canada. So with that in mind, today we're going to cover a couple of different topics. The first is connecting to Will's presentation. What is Volkswagen as an automaker doing to ensure the sustainability and efficiency of our electric vehicles? But number two, if we acknowledge that electric vehicles are more environmentally efficient, how do we increase adoption? Because from that point forward, it really becomes a case of numbers. How do we get those volumes up? How do we get these cars into people's driveways, and why? So with that in mind, let's start with Alberta, a province where we don't see a lot of electric vehicle sales today. In 2021, 94% of electric vehicle sales took place in just 3 provinces: British Columbia, Ontario, and Quebec. That's about a 3.5% total share of the Canadian light vehicle market, and there are several main reasons for that. But the biggest one that we now face today is one of supply. We don't see a lack of demand, but there are a variety of reasons, be it zero-emission vehicle mandates, rebates, etc., that lead automakers to take the small number of EVs they've been producing so far and ship them to these 3 provinces. But we really see an opportunity now to begin driving mass EV adoption across Canada, and Volkswagen will be doing that in a few different ways. But as I mentioned, 3 main topics. The first is we need to make these vehicles right. We need to have an environmentally responsible, efficient supply chain to allow us to build these vehicles en masse and truly take advantage of all their opportunities. The second is we need to make it easy for customers. We need to have these vehicles fit seamlessly into people's lives so that they truly see the value. And most importantly, and this is something for Volkswagen we feel very strongly about, you've got to make it fun. Cars are an emotional purchase decision, like it or not, and so you can't be buying a car because you've been browbeaten to it or because you feel morally obligated to do so. You really have to feel a connection to the product, and we're doing a lot to try and ensure that. So starting with making it right. 4 real key considerations here. The first is production and logistics, energy and charging, battery supply, and of course, battery recycling. So let me cover off what we as an automaker are doing and what other automakers are doing to cover off these topics. For production, the equation is really simple. Obviously, we reduce our carbon footprint, we increase our efficiency if we can build cars locally. So at least for Volkswagen, we've invested $800 million in a new state-of-the-art factory in Chattanooga, Tennessee, to build electric vehicles just for the North American market. Our suppliers have invested a further $2.7 billion to support this plant, including a dedicated battery plant run by SKI just over the border in Georgia. This is what we need to supply the Canadian market and finally begin distributing these cars outside of Quebec and BC to get them where customers want them across Canada. As for charging, there's a variety of companies, including some in the room here today, pushing investment in charging infrastructure, but for us, at least as the Volkswagen Group, we have a massive multi-billion-dollar investment across North America with our companies Electrify Canada and Electrify America, which are building a network of 1,800 charging stations across North America, which will total upwards of 10,000 ultra-fast chargers up to 350 kilowatts, which are industry-leading in terms of their charge speed, allowing some of our vehicles to charge from 10 to 80% in less than 20 minutes. But the big topic that's most important for Canada and highly relevant for Alberta is that we need to have efficient sourcing of materials in the most environmentally friendly way possible. And Canada, believe it or not, is the only country in the Western Hemisphere that has everything we need for the battery supply chain right here under our soil and in our country today. So whether it's the critical materials that Will spoke about or manufacturing resources, additional support materials needed to manufacture and distribute batteries, Canada has everything we need. That's why Volkswagen, as a global company, actually recently signed just last month a memorandum of understanding with the Canadian government to explore opportunities for battery value chain creation and raw material security right here in Canada. Because once again, if we're able to source materials closer to home, reduce shipping, increase investment in environmentally friendly, and of course, we'll say workforce-friendly environments, we're able to make our cars more efficiently. And of course, last topic is battery recycling. Will mentioned there are some companies right here in Canada working on the battery recycling chain. This is something that will become increasingly important over the next decade, but automakers themselves, including us, are also exploring what we can do to contribute to the battery supply chain and recycling, because as Will mentioned, these materials are much more efficient and less expensive to source from recycling than they are to mine from the ground net new. So that covers the environmental aspect of it. But now let's talk about some of the more pragmatic reasons why somebody would want to buy an EV, and more importantly, why we believe EVs are now going to be adopted outside of these traditional areas now across Canada. So for Volkswagen, making it easy starts with the foundation. And this is not unique to us. Other automakers also have platforms like this, but we have our MEB platform. This is a modular electric architecture. Think of it as a giant skateboard, where the floor of the car is a battery with electric drive units, and then we're able to put a variety of different bodies on top of the car to meet customers' needs. The first model that we're launching in North America on this platform is our ID4. It's an award-winning vehicle. It was named World Car of the Year last year, and crucially, it is a compact SUV. That's important for Canada because that is the #1 segment in the Canadian automotive industry. This is the form factor customers want. Now, crucially, for a growing number of Canadians, buying an EV just makes sense. And let's go through some of the reasons why. We now have SUV models, which was critical in terms of adoption, with available dual motor all-wheel drive. So ID4 is no different. We expect that our dual motor all-wheel drive model will represent well over 90% of our sales for this vehicle. Most electric vehicles are now showing ranges well in excess of 400 kilometers. In the case of the ID4, up to about 450. So a really usable daily driving range with, of course, fast charging. The ability to recharge the car either overnight at home, so you always leave with a full tank of fuel, or on the road using a growing network of fast chargers. Low cost of ownership, this is well known. When you're spending less money on the energy that you put into your vehicle, you're spending less money on maintenance, and you're able to take advantage of generous government rebates, the total cost of ownership equation starts to make sense pretty quick. And that's especially true when fuel gets up to $1.50 or $2 a liter, as we've seen in recent history. And last but not least, really important point for Alberta, as much as it is for us in Ontario, where I'm based, these vehicles are well suited to Canadian winter. There's nothing to worry about. They have incredible winter performance, and we've even begun installing things like high efficiency heat pumps to reduce the impact of cold weather on the vehicle's range. But of course, we're Volkswagen, so for us, making it fun is just as important as making it make sense pragmatically. So there's a variety of things there too. EVs are more than a fashion statement, and this is certainly true of any EV. They have instant torque and acceleration. Most EVs can blow the doors off of an equivalent counterpart ICE vehicle in a straight line. But it's not just that. They've also got wonderful handling. You've got a really low center of gravity, which helps you with weight transfer, allows you to more finely tune your suspension, gives you a really enjoyable driving experience, sharp steering, sharp response. And of course, quiet operation. You're not harnessing the power of thousands of little explosions per minute to make the vehicle move. You have lower noise and a more refined and relaxed ride. And at least for us, we've been looking for ways to prove to people that EVs really are ready for prime time. Whether it's on the racetrack, our IDR, we spent the better part of 3 years sending it around the world to smash records at just about every track we could send it to, including where it held the #1 time at the legendary Nürburgring Nordschleife in Germany for many years until our neighbors at Porsche beat it just recently. But whether it's racing cars or even off-road vehicles like this ID Extreme concept that was just revealed, we're showing that electric vehicles can do absolutely anything that gasoline vehicles can do. And of course, we need to capture people's imagination, and at least for Volkswagen, some of that means nostalgia, whether it's the reincarnation of our legendary microbus T1, T2 with the ID Buzz. So this vehicle will actually be coming to North America in early 2024 and will really stop traffic. We just launched it in Europe and it's been a smash success. Or like our sleek, stylish ID Aero sedan, also coming in 2024 to Canada. We are now going to begin to see from Volkswagen, like many other automakers, a full range of electric vehicles that meet the needs of Canadian consumers, that capture their hearts, that capture their imaginations, and really drive them to begin adopting cars, whether it's in BC, in the Maritime provinces, or right here in Edmonton. So with that, just to recap, we got to make these things right. We've got to make it easy for customers. And of course, we've got to make it fun. So with that, thank you very much. And I believe I'll invite Will and Daniel back up on stage so we can have some Q&A.
Awesome. And it's working. Perfect. So we've got about 18 or so minutes for Q&A. So, and we have a mic coming around. So do we have any questions?
Hi there. Thank you all for your time and having the conversation so far. It's been great. My question is really just for Volkswagen. Obviously, there's a lot of investment and kind of forward thought in EV recycling and component recycling right now, or kind of towards the future. Is there anything that Volkswagen as a group is doing today? Because I know there's been some EVs from their brands that have been in the market for a little while now. Is there anything today that, as a consumer, hey, I have an EV, it goes for recycling, there's anything that's happening within the brand today?
Another great question. So to Will's point, the volume so far has been really low. So we do have agreements with some of these local suppliers for ad hoc battery recycling if you have a vehicle that's been scrapped due to a collision or something like that. But the larger scale battery recycling programs will have to be matured and developed over time. But one of the critical elements that we shouldn't forget about with the longevity of battery electric vehicles is actually the step between inception and recycling, which is maintenance. So while electric vehicles are very, very long-lasting. We're seeing incredible performance from our vehicles in market already. A critical element is, of course, they are complex machines. Sometimes things will go wrong. So we've also invested a lot in the training and support of our dealerships across the country so that we can actually do high voltage battery repairs. You're not having to replace the entire battery as a unit. You're able to go in and replace individual cells in order to prolong the useful life of these vehicles, keep them on the road longer, and then eventually, as you say, get to that point where we do effectively recycle the battery and make the best use of those raw materials.
Thank you very much. Any other questions? One over here.
Yeah, so my question is about the electric grid itself. You guys are talking about putting a lot of fast chargers and stuff like that, but how are you guys going to deal with the electric grid that is like pretty much at its max? Yet you guys are talking about building so many, other fast chargers and then chargers at home and all that other stuff. How are you guys dealing with that to, deal with the electric demand that Alberta or Canada will have to deal with?
Okay, so in my day job, I work for an electric utility. I'm also an electric engineer, as I stated in my presentation. The electricity grid is complex. So you have different segments that will experience different things. Generation and transmission are totally separate from distribution and retailing of electrical energy. The ISO, the Alberta Electric System Operator, has stated on the record that the generation and transmission capacity of Alberta into 2050 will be sufficient for their view of uptake of electric vehicles in Alberta, which is quite generous. So from a transmission and generation capacity standpoint, I think we're going to be fine, and the Alberta Electric System Operator has also said that. On the distribution side, there are a lot of things going on, and there will be some pain points. There will be some bottlenecks. Particularly when Electrify America, or Electrify Canada, comes up to a distribution facility operator and asks for 10 megawatts of capacity to be brought on the system. Sometimes that's going to take a while to bring on, sometimes it's going to be exorbitantly expensive, and sometimes they just can't provide it. In those cases, there are alternatives. Battery energy storage, for instance. You can use a battery to store up energy and trickle charge itself throughout the day, and then when you get a huge surge of people charging at 6 p.m. or on Thanksgiving weekend, you can discharge that battery into those vehicles and not have to burden the electric grid. So that's one thing. On the residential charging side, I would say that what I was saying earlier to this gentleman about revising building codes so that houses are built with the capacity to charge electric vehicles up front is an important thing. There are also technology providers that are coming out. If you visit the EPCOR distribution transmission booth, they'll tell you about a device called the AC Dandy Loadmeister. And this is a device that monitors your electrical panel at your home and looks for it to be heavily loaded. If it is, it won't charge the car. When that condition is removed, it will charge the car. So there's all sorts of things that are springing up left and right to help address the capacity issues. And the last thing I would say is that since electric grids existed, they've always grown. When the first homes were installed in Alberta, they had 30 amp electric panels. Today they have 100 amp, 200 amp. So growth is nothing new to the electricity industry, and in fact, it's been growing at a crazy rate throughout the last 100 years. They never envisioned air conditioners, and yet we have them, and the grid is doing mostly fine. There are a few times throughout the summer when there's a heat wave, and the ISO has to issue a notice to large industrial customers that they may have to issue a load shed order. We have never hit a brownout condition in Alberta in the last 10 years that I've been working for the electric utility industry. So yes, it's a concern, but a lot of the sounds for concern are going to cause that concern never to actually manifest. So, anything to add?
I don't think there's anything to add there. That was amazing. Any other questions? No more. So we have 4.5 minutes, and I guess there's something that it would be great for us to drill into more, which is the emissions. Let me just pull up my questions here. Yeah, so the emissions of batteries themselves. So obviously we covered through the presentations that the use of electric vehicles have a much lower emission, or it's based on the grid, a lot less emissions compared to traditional vehicles. An electric vehicle has higher emissions when you manufacture it than a traditional vehicle. Why? Where do those emissions come from?
Well, I mean, I thought Will's presentation did a really great job going through some of the challenges in that. Number one, you've got more raw material that needs to come out of the earth, period, regardless of sourcing location, to manufacture these vehicles. So that will always be a first building block of higher emissions. The other factor that we've discussed is the movement of these materials from source of origin to source of refining to source of manufacturing. So we and other automakers are working hard to cut down that length of supply chain to increase the overall efficiency of the process. But from there, it really comes down to the efficiency of the actual mining operations themselves. All the more reason why we would want to pursue development of that mining resource in companies that have a high ESG standard, like Canada, where we know that everything is being done in an ethical and environmentally conscious way and in a sustainable way so that we can prolong the usefulness of these raw material sources. But I'm sure Will has something to add to that.
Sorry. Thanks, man. I do, actually. So you only have to mine that material once, and then you can recycle it, only losing 5% into perpetuity. And I showed that on that slide. That company, Lifecycle, they have proven in their manufacturing facility that they are able to recover 95% of the raw materials from that battery. So although that first electric vehicle on the lot has a high GHG footprint off the lot, as it is recycled 20 years from now, and then 40 years from now, and then 60 years from now, it will have a continually lessening GHG footprint from its lot, GHG footprint. In addition to that, the mining sector is also starting to adopt electric vehicles. This isn't something that many people know, but if you operate an underground mine, one of your highest costs is cycling air throughout that facility, because you're running internal combustion engine vehicles that are spewing out nitrous oxides and sulfur oxides and carbon dioxide, and those are pollutants to the humans that also work in the mine. So one of their high costs is cycling the air through that mine. So the mining industry is actually one of the industries that is adopting electric vehicles at a very rapid rate because it helps lower costs. And that's something that's going to lower the GHG footprint of electric vehicles. If you think about the refining facilities, they use a lot of electricity. What's happening with electricity? Decarbonization, phase out of coal in Canada. Alberta has phased out more than 50% of its coal. By the end of 2023, there will be no coal power generation on Alberta's grid whatsoever. So the myth of the coal-powered EV will be gone. And then the transportation sector is electrifying, as we're talking about. So the heavy-duty semi-trucks that are moving this battery material all over the place, and these batteries all over the place, they'll be electric or hydrogen, and they'll be much cleaner to own and operate. So the GHG footprint of these materials will continue to go down as the world embraces clean energy and electrification or decarbonization of transportation.
Fantastic, thank you very much. So I think that brings us to a close. That's a good time to finish. Enjoy another couple sessions today, and we're here all weekend, so enjoy the rest of the expo here. Thank you for coming.
Thank you, guys.